Hello everyone, my name is Shweta Shrivastava. I am a software engineer and I lead the 5G development effort over PAWR platforms at Northeastern University. In this part of the presentation, I will be talking about our feature contributions to OAI development and results from our testing efforts. So we started our technical involvement at OpenAirInterface a few months back with a few goals in mind. First, we want to support and accelerate research efforts in 5G by industry, academia, and government by deploying OpenAirInterface 5G network over our software-defined radio-based PAWR testbeds. Second, and also important, we want to contribute to and accelerate the implementation of 5G standalone mode by OpenAirInterface. With these goals in mind, the primary area of focus for us is OAI 5G NR-UE. Now, OAI already has a robust G-Node B implementation owing to extensive development and testing with commercial UEs, first for non-standalone mode and now with the same being done for standalone mode. Hence, our focus has been for the past several months and will continue to be to achieve a robust SDR-based 5G UE implementation that can be deployed on our testbeds. And the plan is to contribute the development of new features towards enabling and enhancing 5G standalone mode implementation, and also to achieve a robust and stable NR-UE implementation by testing and validating on our testbeds. Our primary feature contributions in the last few months have been max scheduler improvements. We completed the modules for extraction and processing of uplink DCI formats, format 00 and 01. We implemented the decoding of DCIs based on size and format indicator, which aids the blind decoding process and enables the NR-UE to receive different DCI formats, which was earlier limited to only downlink DCI. We also removed static resource assignment for push at the UE and enabled dynamic scheduling. The UE now makes use of dynamic resources received in uplink DCI. It also dynamically calculates the uplink slot for push based on slot offset K2, as shown in the figure below. And it supports multiple allocations within a frame and also per slot. The significance of these improvements is that these will allow the G-Node B to now support multiple UEs and schedule for better resource utilization. In addition to the feature enhancements, we also made contributions towards improving the stability of NR-UE. When we first started testing OAI ran on our testbeds, we encountered several failures at the UE. These were due to various reasons, including DCI decode errors, where the DCI was not decoded properly, or sometimes a false DCI would be detected. There were a couple of errors due to memory reference issues. We worked on resolving these issues and are right now looking into a couple of others. The UE process is much more stable now with fewer errors. Very importantly, we will continue to test and validate the UE to ensure we continue to have a stable implementation. We are also working on introducing additional sanity checks in the code to ensure that we catch any unexpected behavior sooner. So going into our 5G deployment setup, we have two large-scale testbeds here at Northeastern where we are testing OAI. First is Constellation, which is part of the PAWR program, and second is an in-house testbed called Arena. The configuration of the two testbeds is very similar, with both using Intel Xeon-based computational nodes and X310 USRPs. The primary difference between the two testbeds is that Constellation uses a massive channel emulator, while Arena performs the transmissions over a real wireless channel or over the air. In addition, we are working with our partners from the PAWR AirPaw program, Professor Vuk Marojevic, Keith Powell, and Andre Kirshner. Keith and Andre have been working on over-the-air testing for 5G standalone mode on their test bench, where they are running OAI with B205 mini ISDRs as shown in the pictures here. So we have deployed OAI 5G RAN on all 3 of these test beds, and we have been testing and running various tests. Our primary objective is to establish a connection between GNode B and UE and to exchange data traffic. We have been using the NOS1 mode of deployment, where OAI, GNode B, and UE connect with each other without a core network. A TON interface is created to PDCP layer, and that interface is used to send and receive data traffic. One of our observations from our test is a poor and blurry constellation. However, the constellation can be improved by setting a carrier frequency, which is an integral multiple of the USRP clock rate, which in this case is what is shown below. This frequency value can be obtained by tweaking the absolute frequency SSP and absolute frequency point A parameters in the GNode B config file. This result is courtesy of the team at IISc India who shared this observation with us. With the improved constellation on the PAWR AirPod test bench, we are able to exchange some data traffic. This slide here shows the results with ping traffic, and this next slide here shows the results with iperf traffic. If we look closely though, we can see that there are packet drops and the performance is very low. To summarize the status over X310s, we see that initial synchronization is achieved and PDCCH can be decoded successfully. However, no data traffic is exchanged as CRC check fails for PDSCH. With B205 mini I's, initial synchronization is achieved, PDCCH can be decoded successfully, and we also see partial success with CRC checks, which results in exchange of some data traffic, as I showed in the previous slide, but with low performance. So the next steps for us are to analyze the CRC failures with the USRPs and identify potential causes, and then of course work on resolving those and optimizing the performance. Here are the overall next steps for our efforts. We are committed to supporting OAI with 5G standalone efforts, and we will continue to contribute to feature development, both in the control plane and user plane. One major priority for us is to debug and resolve issues with data traffic, as I talked about in the previous slides. We will also resolve the remaining issues with UE stability and will continue to test the UE for any issues that creep up as new features are developed. We are also working on a UE cleanup effort with our colleague Francois from Nokia. This effort will help streamline data access in the code. It will introduce more runtime debug options instead of compile time ones and remove redundant ones. And finally, we will deploy end-to-end OAI 5G standalone network over PAWR testbeds. That concludes my presentation. Thank you. And Manu and I are happy to take questions now.